Hello, welcome to watch this demo. Source image is a very hot topic today in the cloud-native world, and Istio is becoming the de facto standard of source images. One of the most exciting things for me is the traffic management it provides for microservice application. But Istio mostly focuses on HTTP and gRPC traffic. For other layer 7 traffic, such as Dubbo, Thrift, Redis, MySQL, etc., Istio had very limited built-in support, or no support at all. But the reality is that we also have many other layer 7 traffic in the images, and we want to manage those traffic as well. That's why I created Aeraki, this project. To address these problems, Araki works alongside Istio, providing an extendable source image control plane to allow us to manage any layer 7 traffic in a source image. So the idea is very straightforward. Araki gets the system services and virtual services from Istio, generates all the needed XDS resources for those services, and uses NOA filter API to push the XDS resources back to Istio. Then Istio will merge this NOA filter with the XDS resources that generate by itself and distribute the merged XDS to the NOA data plane. In this demo, I'm gonna show you how to manage Thrift and Dubbo traffic in an Istio source image with the help of Araki, such as version-based routing and traffic splitting. Okay, let's dive into the demo. To run this demo, we need a Kubernetes cluster that has Istio 1.8 preview profile installed, and you will also want to install Araki to manage Thrift and Dubbo traffic. To save your time, I already have all the control plane components and demo application installed in my cluster. You can see here, I have Araki and Istio installed in the Istio system, and I also have a Dubbo application in the Dubbo namespace, a Thrift demo application in the Thrift namespace. For each demo type application, we have a client. We also have 2 versions of servers, so we can demonstrate how the traffic are routing between different versions of server. So if you do want to run this application, like demo application by yourself, I do have a GitHub repository here, github.com Araki framework Araki, and you can find all the YAM file you will need to run this demo in the test folder. So if we take a look at the config dump of the UNWE sidecar, we can see there is a Thrift proxy in the listener, in the outbound listener of the client. Okay, so by default, it will be a TCP proxy generated by SDOD, but Araki will generate the Thrift proxy for our Thrift service. So we can say the default load is just send the it can request to this cluster. And now we have two versions of server in this cluster, V1 and V2. Let's verify that. So if we take a look at the output of the client, the demo client, we can see the response are from two versions of server, the version 1 and version 2, and the request are forwarded by this university card to the server equally to version 1 and version 2, because we don't have any routing rules right now. So the default load balancing policy of the university card is just like 15%, 50% non-loading. Okay, let's try to add a routing rule. Okay, this is virtual services. So we use virtual service to represent the routing rule of Thrift. In this virtual service, we can say that all the traffic will be sent to version 1 of the Thrift server. Of course, we have a distinct rule to represent different versions of these services. So let's try to apply our virtual services to route the traffic to only version 1 of the server. So we have virtual service here. Okay. You can see that the request from the client to this host will be forwarded to version 1 of the server. So let's try to apply it. I need a few seconds to take effect. Okay, the client has been disconnected by the proxy because we don't have RDS yet. We need to rebuild the listener. Now we can see that all the response are from the version 1 server. Okay, let's try route the client to version 2. Now all the requests from the client are forwarded to the version 2 server by the invoice card. Then let's try traffic split. Okay, we have a splitting rule here. So we want to load 30% of the traffic to version 1 and 70% of the traffic to version 2. Okay. From the output of the client, we can see roughly 30% of the traffic has been routed to version 1, and 70% of the traffic has been routed to version 2. So all this traffic behavior behaves exactly as what we intended to do. Then let's try Dubbo demo. Okay, that's all for this demo. I hope this will be helpful. I hope Aeraki can help you build your own sales image. And we plan to support most of the widely used protocols such as Dubbo, Thrift, MongoDB, Redis, MySQL, etc. If you are using a proprietary protocol, you can also write your own Aeraki plugin to support it in your sales image. Thank you.